These are the notes for 8-2 Part 1. We're analyzing arithmetic sequences. So the definition of an arithmetic sequence is a sequence with a difference of consecutive terms called the common difference. It just means you start with a term and you're adding a number to each term to get to the next term, okay? We say the common difference, we give it the letter D. That's a D. And then, like the common difference here, I would have added 3. So my common difference was 3. And I would have added 3 to get to the next term each time. And that has to be the same for every term. If you get a visual graph to determine if it's arithmetic, it makes a straight line. Okay, they are linear. If you're given a table, as you go up each term, you see that, oh, I'm adding 3 here to get to 4. I add 3 to 4 to get to 7, and I add 3 to 7 to get to 10. And so that is the same every time. Here is the formula that we will use to find our equations based on some information that you'll be given. Now, you can also write this like this, where it's AN equals A1 plus, and that D can come out front, and it's the same thing, okay? So let's determine whether these sequences in 1 through 4 are arithmetic or not. So the first term, remember, arithmetic means we want to see if I'm adding a number every time. So if I take the second number and I subtract the first number, so in this case, -2 minus -9, I see that I added 7. Okay, it gives me a positive 7. Well, let's see if it's the same thing between the 2 and the 5. -2 plus 7 does equal 5. 5 plus 7 does equal 12. And 12 plus 7 does equal 19. So this would be arithmetic. So yes, it's arithmetic. All right. Now, to get from 23 to 15, right here, I'm actually going to subtract 8. 23 minus 8 is 15. Well, 15 minus 6 is 9. 9 minus 4 is 5. And 5 minus 2 is 3. And since that is not consecutive, this is not arithmetic. Okay, and remember, looking at the graph, you just determine, is it a straight line? This is not a straight line. This looks like an exponential graph, not a linear graph. So it is not arithmetic. This looks like it makes a straight line. It looks linear to me, so I would say that is arithmetic. All right, now we're going to start using that equation, and we are going to write a rule for the nth term of the sequence. So you write the rule, that's step 1, and then it wants us to find a random term, and it tells us it wants the 15th term. That's what A15 means. All right, so we're going to start with the equation that was given. AN equals A1 plus N minus 1 times D. All right, well, I can tell by what I was given, this right here, this 7 is my A1. That's the first term in the sequence. And I need to find the difference. Well, what am I adding to get to the next term? Well, 7 plus 3 is 10. 10 plus 3 is 13. 13 plus 3 is 16. So I know that 3 is my D. That's the difference to get to each term. So I can plug in what I know. Well, I do not know AN. That's the equation I'm trying to find. But I do know A1 is 7. That's that first term. Plus N minus 1. And I know D is a positive 3. So that is times 3. And it's in this situation why I wrote that it can be written with the D in front. Because with the D in front, it would look like how we're used to distributing. That means the exact same thing, okay? So I need to distribute the 3 to both terms inside. So I have AN equals 7 plus 3n minus 3. Because 3 times n is 3n. 3 times negative 1 is negative 3. And then I have some like terms right here, so I'm going to combine. So an is going to equal, I have a 3n, and then I have 7 and a negative 3. They add up together to be a 4. Okay, so this is the rule. It says write a rule, so we just did that. But then it wants us to find the 15th term. So to find A15, that means n is 15. So 3 times 15 plus 4. Well, 3 times 15 is 45, plus 4 is 49. So there's the 15th term. All right, number 2. A1, again, is that first term. That's A1. And D is going to equal what I'm adding to get to each term. So it's 15, and it looks like I need to subtract 7, so add a negative 7. So D is negative 7, and I'm going to plug it in. All right, so I'm going to plug it into the equation I know. So AN is going to equal A1, which is 15, plus D, which is a negative 7 times n minus 1. And then we are going to distribute that negative 7. So AN is going to equal 15. And then negative 7 times n is a negative 7n. Negative 7 times negative 1 is a positive 7. Combine our like terms. So I still have that negative 7n. And then I have 15 plus 7 is 22. So there's my rule. And then I need to find that 15th term. So A15 is going to equal negative 7 times 15 plus 22. And you should get negative 83. Okay. So those two rules, one of them had where D was positive, one had where D was negative. Even though with negative, it looks like you're subtracting each time, it's still addition of a negative term, so it all still works. All right, number 3, the sequence -2, -5/4, -1/2, +1/4. We need to figure out what we're doing to get to each term. And looks to me, like if I take a -5/4 and I subtract the -2, I actually get a 3/4. Okay, well, if I add 3/4 to a -5/4, I get -1/2. So that is going to be my D, because that is what's going on each time. This -2 is A1, and I'm going to plug it in my equation. So I have AN is going to equal A1, which is -2, plus D times n minus 1. All right, I'm going to distribute 3/4, so -2 plus 3/4 n. What did I write? 3/4 n minus 3/4. Combine some like terms. So I have 3/4 n minus 11/4. There's my rule. And then it wants me to find that 15th term. So I'm going to plug in 15 for n. And that equals 17/2. All right. Number 4. Now I gave you a fraction. Now I'm going to give you some decimals. So we find our difference. Well, this time I'm going to subtract, or you can considering it adding a negative number. Looks like I need to take away 0.8. So that's going to equal D. 2.3 equals A1. And I plug it into my equation. AN equals A1 plus D, which is a -0.8 times n minus 1. Distribute the -0.8. And then collect like terms. -0.8n plus 3.1. There's my rule. And then I want the 15th term. -0.8 times 15 plus 3.1, and that equals a negative 8.9. Now, for any of these, once you get your rule, and if you think the rule doesn't look correct, you can always plug in n being 1, n being 2, n being 3, and make sure you get the numbers that are in your sequence to check. So this is the video for 8.2 part 1.